Hey, Dory.
So if you look over your honors geometry, on Wednesdays we wear pink. Man, we're already on Wednesday, guys. Good stuff, okay? SWBA. Simone, what does SWBA stand for? Students will be able to. That T is silent. Use, I'm supposed to have a use there. Use the triangle proportionality theorem and use proportional relationships. Use the triangle proportionality theorem and proportional relationships. Section 6.7. Hey, what do we notice about this section?
It's yellow.
It's
6.7.
the last one.
It's the last one. Okay? It's the last one. So what's that mean, guys? Probably a test coming up, right? Okay, everyone's pretty excited about this, okay? We have a test coming up, okay? Everyone, I always love your facial expressions. It's just a joy to me, okay? So, thank you, okay? So, test coming up. So just heads up on that, guys, okay? So we're looking at that. Reviewing Fun Sock Friday, like it says over on the board, and then we're taking that test. When's it say? Tuesday, next Trooper Tide Tuesday. Yeah, that'd be the next class, okay? So just a heads up on that, on what we're looking at, okay? Any questions? Okay. Also, congrats to show choir Monday. That's pretty awesome. Got gold. Got the gold award. It was called, right? Yeah, good stuff. That's awesome. So congrats to show choir and all the crew and everything like that. That's amazing. So
Who's in show choir?
pretty cool. Okay. Ava's on the crew for that, right? Anyone else in here doing any involvement with show choir?
I'll do it next year.
Okay.
Hopefully.
Yes. Okay. So, triangle proportionality theorem is what we're going to start with here. So, theorem. What away?
Oh,
okay.
no.
If a line,
Something else we have to do. Something else we use.
if a line parallel to a side of the triangle intersects the other two sides, then it divides those sides proportionally. So what it says is, if a line is parallel to another side, to a side of the triangle. So here we have line EF is parallel to the side BC. And we're saying, and it also intersects the other two sides of the triangle. So it's parallel to one side, and it intersects the other two. So EF meets these qualifications. It's saying then it will divide these sides proportionally. So we can make a proportion for how it divides the sides. So we can say EF cuts these sides into AE and BE, and AF and FC. So that means AE over EB is equal to AF over FC because these lines are parallel. So this proportion would be true. So we're saying even though AE and AF might not be the same measure, and EB and FC might not be the same measure, we're saying that this proportion would in fact be true. Let's try and use this a little bit and see if it kind of comes to life a little bit, okay? So, if we were just on problem A, if we were trying to find the measure of, let's call this, let's call it smiley face. We don't use smiley faces often as variables, okay? Let's call it smiley face, okay, CY, okay? Let's get a little fun with it. You need to get a drink.
Yeah.
Gotta go get a drink.
Yeah.
So here we can use the triangle proportionality theorem. What's that a call for, Steve? Okay. So we have this line XY parallel to the third side BC, and this line is intersecting the other two sides. So we're saying that it must cut these proportionally. So we can set up a ratio here. We can set up two ratios and set them equal, aka a proportion. So we could do, maybe we could do 10 over smiley face is equal to 9 over 4. Boo!
That was scary.
Kind of scared out of you. So we can set up this proportion because of the triangle proportionality theorem, because these two lines are parallel here. So then we can solve this proportion like we have been. We've been solving proportions, so we can cross multiply. 4 times 10 is 40. 9 times smiley face is 9 smiley face. we can divide both sides by 9. Okay, and our smiley face is equal to 40 over 9, which could also be converted into decimals and whatnot as well. Wait, I did this wrong. Oh, I needed to change a number.
What?
Oh, I should have looked at my notes. I need to change this in the future.
Oh, she's back.
Change. To leave right here?
Yeah.
Okay. Sorry. Sorry guys, I messed up. This 9 is supposed to be an 8. This 9 is supposed to be an 8.
Really doesn't.
It actually fixes everything.
Really does. Good thing I wasn't writing it down anyway.
Ooh. Okay. Sorry about that, guys. I forgot I changed that in my notes, and then I just started working through it without looking at my notes. And I was like, oh, botch.
I don't want
Botch.
Yeah. So then smiley face is 5. So that means the length of CY is actually 5. And if we look at that, I think we can see that to be reasonable. That if this small section's 4 and the big section's 8, well, this big section's 10, that's just a little bit bigger. And this small section would be 5. Also, what is 8 compared to 4? Okay, 8's double it, or 4's half of 8. And then so 10 and 5, what's the relationship? The double or half still, right? So still that same relationship. And that's true here only because these two lines are parallel. If this line was not parallel to the third side, we could not do this proportion. We couldn't find any of this. But we can do that because it's proportional. Because we don't know that otherwise. Unless we have these two lines parallel, we can't know that. Yes. Are you saying if we know they're parallel, do we have to do this? If you can see the pattern right away, then no. There won't always be exactly that pattern where it's like double, where it works out super nicely like you saw in our homework. But yeah, if you see that pattern right away, cool. Yeah. It's Wednesday, my dudes. On Wednesdays we wear pink. Okay? Okay. It's also 4 months and 8 days, if you guys are wondering. Okay? Even if you weren't, it's like a period. Yeah. Okay. So, can't wait. Yeah.
You should invite our whole class.
I wish I could.
You should have 2 weddings, one for like you guys and like one for the school.
Yeah, just host like, we can just like have it in the gym.
Yes.
Ew.
I
Yeah.
will decorate it for you.
Oh, perfect.
Oh.
She deserves better than me.
No, I meant then a wedding in the gym.
I know, but I'm also saying is true. She's amazing. She's like super hot belly. Like, yeah. I'm just hoping she doesn't realize it or like we get married because I'm in trouble. But
She probably can.
What if they English is
Yeah, I don't know.
Oh my god.
what?
She's crying.
It's true. She's way over the She doesn't believe it, but it's true. Okay, on B. Any questions on A? Okay. If I ask you to guys to find the measure of segment PM, if I ask you guys to find
I did.
the measure of segment PN, measure of segment PN, okay, I want you guys to try finding that using our triangle quadratic theorem. Once you have it or have questions, raise your hand.
Did you see it?
I'll check. No, I just
There's one. But that is technical. You might take
Can I show you
this
this?
Yes.
Is it good?
Missed it.
6 B's?
You can't tell me that's not good. Yeah.
Oh.
Don't worry. I'll make up.
So if you're doing this 5 over this x, that's fine. But then,
I love it. And then my head.
so there's lots of different ways you can set it up. That's what that is.
Yeah, hold on.
So we have to make sure it's still lined up that way. Does that make sense?
That's what I do when I'm home alone with my brothers.
Let's talk about this one up here. So if we call Pn, what do you guys want to call this up? X, okay. Let's get creative. So, no, that's what I call it.
Squiggly X. We're gonna call it
Squiggly X. Like,
So it's like the two similar signs like crossing.
right?
So it's only weird.
Okay, Squiggly X. Okay. So, trying to find the squiggly X here. So, Jocelyn, give me what you did for your proportion.
First time or?
The second.
15
Nope.
No. Where's it at? Oh, 5 over 6
Okay, 5 over squiggly X here.
equals 2.
Yeah. Okay. So that's one way we can set up this proportion. Is that the way everyone probably did? No. Okay, but it's okay. Because what Jocelyn did was she took the right side over left, and she did the same parts. She did the bottom part and bottom part here. So vertically, we still have it lined up for bottom parts. And then on this other one, she did the top part and the top part, so vertically it's still lined up top over top. And if we were to line them up horizontally, like we said I had to check, well, it works that way too, because this is both on the right side, and this bottom here horizontally is both on the left. So this is a working proportion, just fine. So we cross multiply, and we get 15 is equal to 2 times squiggly x. Now, even if you had a different proportion, set up, did you get 15 equals 2x or 2x equals 15? Yeah. So we arrive still at the same answer as long as we have an okay proportion, okay? I'm guessing a lot of ours looked kind of like squiggly x over 3 is equal to 5 over 2, or the reciprocal of that. 3 over squiggly x equals 2 over 5, right? And that would give us the same answer. So either way, we divide by 2, and then we get our squiggly x is equal to 7.5. So aka that's what the measure of Tn now is 7.5. Questions on that one? Ding, Joe, and Liddy. Okay? Let's go ahead and flip the page, okay? Now, every time we have a theorem, we seem to always also use the converse, okay? Now you're gonna a lot of times. What's the converse again? Yeah, opposite how? Yeah, flipped. Okay, so we have opposite not, opposite flipped. Okay, this is the opposite flipped. Okay, we're switching the order. So here we said on the original, if a line is parallel to a side, intersects the other two sides, then it divides them proportionally. Now we're going to go the other way around. We're going to say if a line divides the two sides proportionally, then it's parallel to the third side. So if a line divides two sides proportionally, then it's parallel to the third side. So it's just the opposite. It's just the reverse order of that. So the first one just went with, we know they're parallel, so it has to be proportional. This time we're saying, we know it's proportional, it has to be parallel. So we're saying here, if line EF intersects the two sides AB and AC proportionally, where AE over EB is equal to AF over FC, or any rearrangement of those that are okay, like we talked about, then lines have to be parallel. Okay. So on letter A, we're asked to verify or check or prove or show that segment MN, let's forget, is parallel to segment KL. We're asked to check that segment MN is parallel to segment KL. Now, according to our converse of the triangle proportionality theorem, how could we prove, according to the converse of the triangle proportionality theorem, that these two are parallel? By setting up a proportion and seeing if it is equal. By setting up a proportion and seeing if it is equal, okay? So can somebody help me set up a proportion here? That might work, Sarah.
21 over 42
21 over 42
equals 50 over 30.
equals 15 over 30, okay? That would be one of the ones we could do, okay? So Sarah took the left over the left and top over bottom. So the left part and the left part of the top bottom sides. Or excuse me, that's not right. Sarah took the left part over the right part over the right part of the top. And so the other one, she also took the left part over the right part of the bottom. Maybe I misspoke entirely. Totally could. Jocelyn just asked, could we do 21 over 15 is equal to 42 over 30? Yeah, we totally could. Because once again, we're not mixing up sides here. What we could not do is like 21 over 15 is equal to 30 over 42. That's one we couldn't do because of number flipping it. Okay. So then we can verify that these are the same. So either you can jump right to actually dividing these, 91 divided by 42, and get 0.5, or you can reduce fractions saying, hey, 21 goes into both of these, right? 91 goes into both of these, and it's 1 over 2. Well, 15 goes into both of these, it's 1 over 2. So are these proportional? Yeah, when you get down to the same number, they're the same thing. They're proportional, just like we did with similar triangles and proving that they're proportional, the ratios are equal. So this verifies that these segments are parallel. According to this converse of the triangle proportionality theorem, if they're proportional, then they have to be parallel. So yes, you could say segment MN is in fact parallel to segment KL. And the work here, that's our proof. That's what shows, hey, this is true. Questions on that? Thank you, Liddy, okay? Hey, a student on letter B, a student states that UV, segment UV, must be parallel to segment ST. Saying, hey, these two segments have to be parallel. Do you agree? And then why are we not? Let's take a second and think about this. As if you think we could either prove that true or prove that false. You don't just accept it one way or the other. Think, could we prove that true or could we prove that false?
I believe it's true. I believe it's false.
Start giving me some reasons. Start giving me some reasons and arguments of why you think this thing. Okay, Justin?
Okay, let's say we side SU is equal to UR.
Okay.
So let's put some numbers in. Let's say side SU equals 7.
Okay, so just hypothetically call it 7.
Okay, which means UR equals 7.
Okay, true.
And so our segment RV is congruent or equals VT. So let's say 10.
Okay, let's just say a different measurement. Cool.
So if we make a proportion of this, they're equal the exact same.
Okay, because what would the proportion be?
It'd be 10 over 7 or 7 over 10.
Okay, we could either do like a 7 over 10 is equal to 7 over 10, and they're the same. Could we also do like 7 over 7 is equal to 10 over 10?
Yeah.
And so is this working out? Would this work with any numbers? Is that special to because of the fact that Justin chose 7 and 10? Yeah, that's what we have to ask is, is that? And no, it wouldn't be. Because even if we just put in here, guys, if we just put in X and X, where it could be literally any number, and Y, just to prove it could be any number, so we'll do it with the variable. X over X is equal to Y over Y. Well, X over X is 1. Y over Y is 1. You could also cross multiply to see if you get the same thing, and XY is equal to XY. So, yeah, I would agree. Okay? So I would agree, yes. And this is our work. So why are we not? I'm okay with this being the explanation on this one. Okay? I really am okay with this being the explanation because that's fine. Or you could say, you can write out the sides are divided proportionally. Okay? The sides are divided proportionally. That's true. Okay. Question on that one? That one's kind of a thinker, isn't it? Okay, I like that. Maybe I'm the only one. Okay. Have I talked to you guys about Cookie Crisp in here? No? Cookie Crisp in here?
I don't think you have.
No, I mean that's perfect.
I did it.
I respect that. Okay. So last summer I bought a house. Okay, bought a house last summer, and now, and And when I got this house, Hannah's family decided, you know what? This guy that she's dating at the time, we were dating, this guy she's dating, he's not too bad, I suppose. We'll get him a household present. So he asked me, hey, what kind of stuff would you want? What kind of like food, stuff would you want us, so that way we can help, kind of just get you set up. We can see some like paper towels, some toilet paper, and some food. And I'm like, oh, that's really nice of you guys. And so I was like, well, my default for food I would never buy myself because I don't want to spend the money on it. But like if someone else is buying it for me, are pizza rolls and like sugary cereals. Like I've never bought pizza rolls for myself, but I love pizza rolls. So like sometimes like I'll dog sit for people and like they'll like buy my food like while I'm like staying there. And so like I'll have my pizza rolls and sugary cereal, usually Cap'n Crunch. And so I ask for pizza rolls and Cap'n Crunch and Cookie Crisp. And because like they all slap, and like I never buy any of these for myself, so it's like kind of like a treat yourself moment. Okay. And so now Hannah's family is like pretty healthy eating wise for the most part. And so like they were like, okay, we'll respect what you asked for, but like they were like looking for like the cereal, and they knew what Cap'n Crunch was because like it's popular, okay. But Cookie Crisp is not as popular or as advertised, and so like they were like having trouble finding it in the store, and they had to go like ask like some of the workers like, hey, do you guys have this like Cookie Crisp? Like they weren't even sure like if they were saying it correctly and stuff. And then and then they've been making like jokingly though, like somewhat like kind of like joking, judging comments about like, I don't know, like pizza rolls, and Cap'n Crunch, Cookie Crisp. Hey, I'm like, I don't eat it all the time. And like, for example, like how like cereal lasts for a while if you don't open it. Like it lasts for like a long time, okay? So like this was last summer, this was last July, and I think pretty hard there. And so like I just opened this Cookie Crisp like less than a month ago, okay? For example, so like it's not like I just like went through it like crazy. Now, granted, I did make it through the pizza rolls in like a week, but that's beside the point. But like, anyway, but like I just opened the Cookie Crisp like a month ago, and now Hannah was over, and she had never had Cookie Crisp, which is just sad, okay? And like she was like, I want to try some, I'm like, okay, sure. And so she tried some of it, and she's like, this isn't even that good. It doesn't even taste like cookies. And I was triggered. I'm like, Hannah, you don't even deserve to be eating this right now. Please just put it away. Like, I was just sad and upset. So anyway, I was big sad.
She's not wrong.
They're not that
Disgusting.
great. Like after a while,
We don't
you start
get
getting
cereal
like
in my
soggy and like.
Just tastes like
That's why you eat it quickly.
No, even if you do, it just.
No, it tastes like cookies in cereal form.
You say cardboard too, Peyton? Yeah. You say cardboard.
Go with her. Leave.
But like with like a honey flake
Yeah.
frosting,
Yeah.
disgusting.
Cookie Crisp slaps.
You know what else slaps?
No man worth that.
Hey, have you ever had that one cereal where it's
I don't
like,
trust your cereal.
no, I swear, this one's awesome. It's like Cocoa Puffs, but then they put the marshmallows in it from Lucky Charms, and it's so good.
You like that big of like.
have you ever had it? The one where it's like the bad,
Let's go with
like
your
the Cocoa Puffs and the marshmallows. Has anyone had that?
I've
Yeah,
had like
it's
the
so
Cap'n
good.
Crunch with the marshmallows thrown in.
No,
That was pretty good.
That sounds gross.
Once again, I don't trust your cereal judgment. And this is why, further proving why I should not trust your cereal judgment. Breathe, you're gonna get triggered again. Okay. Anyway.
Over cereal?
Yes!
Yes.
Passionate.
Who cares?
That was funny. I'm laughing.
Finding an unknown height. We have this saying called indirect measurement. This is not what I expected, guys. I expected backup from you guys and be like, yeah, Cookie Crisp is amazing. I love Cookie Crisp. And I didn't get a single bit of that.
I've never had it. So
I can't judge it.
Actually, I've
I
had it and I like
love
it.
the
So.
Cocoa
I can't remember it.
Yeah.
Mr. Cosell, I love it.
Oh, wait.
Thank you. Thank you. A few of you are saying, you guys get A's. Everyone else
can't
fails.
Never.
You guys might not be my favorite third hour
Oh,
honor.
Cookie Crisp are the bomb. I didn't know what you were talking about.
Yeah, thank you, Dave Nakasima. I appreciate even the fake support at the end.
No, you guys
I know.
are really good.
I'm fine with it, but I'll accept it.
You should bring some cookie crisp.
I'm okay with it being shallow.
They wouldn't last. he'd be in that bag munching on them, like running back and forth.
Just delicious. They slap. It's like it's best when you put it with milk. Like, you know, like some cereals, like you can eat it by itself, like dry, like it's perfectly fine.
Yeah.
And it's like some cereals, it's like not. Like this is one where it's like it's okay dry, but like when you put it in milk, slaps.
What cereal is ever okay dry? I don't eat any cereal.
Uh,
A few. I like Captain Crunch by
Okay.
Indirect measurement means it's not direct.
No.
Whoa.
Okay, what? Okay, so it means you're basically not just going up and down and with a tape measure going, oh, it's this long. Okay, so it involves using the properties of similar triangles to measure heights or distances that are too great to be measured directly. So it involves using the properties of similar triangles to measure heights or distances that are too great to be measured directly. And actually, if it was nice enough out today and there was actual sunlight, we could go outside and we could actually measure the height of the flagpole without actually measuring the height of the flagpole.
Well, actually.
But yeah, it'd be super good.
Let's go.
Well, you can't see shadows today. You need shadows in order for it to work. Okay. On the light pole,
No, like shine it at the light pole.
Wait, what? That
You're
is
not-
very large. You have to go to a distance high
you
enough.
have a flashlight that big?
No, it's
Yeah.
not that big, but it would still
No,
shine.
you need a flashlight to
Because
the size of
it would need to cast the whole shadow of the flagpole
Then
for it
use
to work.
something smaller. Then you do it with like a ruler.
Oh,
Yeah.
goodness. Even then, you need a flashlight as big as that ruler.
Yeah, or the person. But, if it's a sunny day, how about this? On Friday, if it's sunny out, we can go do it. Okay? Is that fair?
Alright, let's do it.
Okay. On Friday, if it's sunny out, we can go do it. Okay? So, it involves using the properties of similar triangles to measure heights and distances that are too great to be measured directly. Okay? It's like a lot of times it can be used for like buildings or like flagpoles, stuff like that. Okay? So, example 1. In order to find the height of a palm tree. See this nice little palm tree over here? Okay? You measure the tree's shadow, and at the same time of day, you measure the shadow cast by a meter stick, so it's 1 meter tall, and you hold it at a right angle to the ground. Why is it important that we have it at a right angle to the ground?
It's a different angle. It might cast a different shadow.
It's a different angle, it might cast a different shadow. And what angle would our palm tree be at?
90.
A 90-degree angle, right? One like your palm tree's at a right angle here. Okay. And now, why do we have to have it at the same time of day? It specifies same time of day. Why is that important?
Because the sun will be the same.
The sun will be in the same spot. Because if it's a different spot, would that be a different angle?
Yes.
Okay. And the thing is, for it to be a similar triangle here,
Bad drawing something.
I know, it's some face.
That's good for him, though.
Thank you. I know I'm like somewhat backhanded, but I'm gonna take it. Good for him. I'll take it. Okay. Anyway, so we have the sun up here, and it's casting the same shadow on both of these, right? So it doesn't matter how tall someone is or something is. The sun's hitting you guys at the same angle. Okay, because of how far away the sun is. Okay, so where it ends up being, you know, like even if it's slightly different, it's so small, it's not even measurable. So, do we have similar triangles? Yeah, by angle similarity, right? We have to share the right angles, and we share the angles from where it's hit by the sun. So we have similar triangles. So, could we find the measure of this palm tree? Yeah, we totally could. Is this just using the same kind of stuff we did last section, or 2 sections ago as well? Yeah, it ends up just being that same kind of stuff. Just here, we're applying it to like sunlight and palm trees. Or on Friday, if it's nice out, we'll apply it to people and flagpoles. Okay. Can somebody help me set up a proportion here? Okay, Sarah?
7.2 over x.
Okay.
Equals 0.16 over 1.
It's 1.6.
Okay. 7.2 over x is equal to 1.6 over 1. Okay. So Sarah went the shadow of the palm tree over the actual palm tree is equal to the shadow of the meter stick over the actual meter stick. Okay? So if we go vertically, we're both dealing with palm trees. Vertically, we're both dealing with meter sticks. Horizontally, the top's both dealing with shadows. Horizontally, the bottoms are both dealing with the actual heights. Okay, question on how that one's set up? Could we set it up differently too? Sure, totally could. You do like 7.2 over 1.6 is equal to x over 1, for example. Okay. So we would cross multiply here, and we get 7.2 is equal to 1.6x. 7.2 times 1 is 7.2. 1.6 times x is equal to 1.6x. Oh, really? Divided by 1.6. You don't say. Okay. X is equal to 4.5. So, how tall is this palm tree? 4.5 meters. 4.5 meters. I suppose.
Oh my gosh.
Are we done yet?
I have a hole in my sock.
Well, how else would you get your foot in them? Any questions on number 1?
Not funny.
I love that one. I know, thank you. They say you only need one good laugh for a joke to be good. I could be my own, but I wasn't my own that one. I didn't need my own. Let's go into example 2. Okay. Okay. Example 2. Wow, I don't do that too.
Who leaves their kids?
So let's go ahead and try number 2. I want you guys to try number 2.
That's
That's law.
what I was thinking. Sid, the kid from,
Oh.
Dude, that is
What?
so weird.
Look what you've
Evil-
done.
Evil kid? The
Yeah.
evil one? Yes. I see it.
But in unison, it just sealed it. He has no room to argue now, so thank you guys. And when you have it, or have questions, I want you to raise your hand.
I'm not gonna be a garbage man when we get terrible.
I mean, I want to be a garbage man. This is like fun.
Oh wait, I did 70.
Yeah. Oh, no. Oh, nice. Yep. You could look to simplify 2 first if you want to. Double check. Take it. I have, but it's always into the wall, and I catch myself. But it could be fatal. Walk by as I just
I had to remember this and just like kicked it, pushed it over. What do you mean? I don't think I would do that. I'm really slow. I'm Justin.
You're Justin, you're funny. You gotta shake their hand.
No.
Shake their hand. Make
It
me.
worked perfectly.
If you don't shake their hand, I'll shake you.
Wait.
I simplified.
Someone's at the door, but don't.
What I did is
I
I did.
can't do
I
anything.
simplified.
They're using tier 3 car or 4 car.
Oh no, no, no.
That would be a mistake.
Wait, what do I simplify it around?
You have 128 and 48.
Four,
There's
six.
lots of numbers.
I know what's the biggest.
Nice. What's up, guys? I want the prints. That's my vibe, guys. High five.
Every time they come by, I always go to that.
Sorry, I thought you did weird.
She's like, oh my god, I'm so sorry.
Ben, I'm sorry. Ben.
Ciao.
Careful, please, like numbers.
That's a lot of things.
It's all my Algebra 1 material for next chapter.
That's all of it?
For next chapter? Yep, for Algebra 1. This is notes, all these different ones, worksheets. Here's the test. But it's also Mr. Mounts. But I just, we use the same materials, so I just print it and then I just give them copies.
It's basically the same thing.
Because we want to teach the same class.
But you're off.
No, not for Algebra 1. Okay, let's talk about this one up here. So we have Sid. Okay. Yeah, sure. Okay. Or it could be Justin. Okay. Over here. Okay. As we discussed. Okay. So there's Sid. Okay. And then we have this the sun up here. Okay. There's a shadow. The sun's shining on it, right? See if I do any better this time. I feel like that's better. I feel like I did better.
Oh, yeah.
Leave it alone.
Definitely better now. It's a good song, actually.
It was better than your last.
7 out of 10.
Good for, I'll take it. What was the first one then? I don't want to know.
10 out of 5 out of 10.
Mess up.
10 out of 7.
Solid. 3. Like, you can't have a bad son.
Well, that's apparently not true.
Well, they're wrong.
They don't like it.
So somebody give me an example of how this can be set up. Owen, phone's hearing you.
72 over H.
Okay.
48
Awesome. That's one way you can do it. Go away. Okay. So 72 over H, 48 over 128. Awesome. Okay, we can do the height on the top. We can do the shadows on the bottom. We can sit on the left. Or see, not sit. We do the heights on the left, shadows on the right, sit on the top, flagpole on the bottom. This is kind of like that example I was talking about, right? That we can do in real life. We can go out to a flagpole and actually do this and find the height. So here, we can look to simplify 48 over 128. Owen, did you simplify or did you just cross multiply? Okay, what did you simplify by?
I think there's 2.
Okay, what did you get all the way down to? 3 over 8. So that'd be divided by 16. And this would become 3 over 8. So then we cross multiply, and then 72 times 8 was 576. Okay. Is equal to 3h, and divide both sides by 3. And then h is equal to, what'd you get on? 192. So what's the height of the flagpole? 192 inches. Okay. Questions on that one? Did we have to have that portion to start off with, or could we have a different one? We could have a different one. There's lots of different combinations. Okay. Okay. We'll do one of these two. Okay. We'll do one of them, but we won't do the other. Okay. In real world situations, real life, you might not be able to measure an object directly because there's a physical barrier separating from the object. So it might not only just be because like a flagpole's really tall, okay, or a palm tree's really tall. There might be actual physical barrier, okay. So we can use similar triangles for this as well. So a hiker is going to find the distance across a canyon, which is D here. That doesn't make sense for that to be distance across the canyon. The way the picture's set up, I don't like that. We'll pretend that makes sense though for now. She locates points as detailed in the picture below. Try and find this distance, okay? This doesn't make any sense. I super need to change this problem. No, I did this last year too. It's just I realized like different things I wanted to change then, and I'm realizing more things I want to change now. Yeah. So I'll just realize more every year. But I cough or sneeze. Okay, so we use similar triangles here as well. Can we prove these triangles similar as of now? No, but can we also find other pieces of information that can help us? What else could we do? Say, it's true. Which one? Vertical angles, right? Angle WZB and angle XZY are vertical angles. And now can we prove the triangle similar by angle and angle? Yeah, now can we set up a proportion to solve for D? Totally. Somebody help me set up this proportion. Okay. Kayla, I'm gonna have you set up this proportion. Okay. That would super work. Awesome, okay? So, let's see if I don't botch the thing this time. On the left, we have the sides between the two corresponding congruent angles. On the right, we have the sides next to the right angles, okay, with the corresponding sides. Horizontally on the top, we have this right triangle, which is smaller. Horizontally on the bottom, we have the left triangle, which is bigger. Okay. So now we can simplify this. So this is one way we can set it up. We can simplify 400 over 600. Oh, boom, gang with those zeros. 4 over 6. Now it becomes 2 over 3. Is that like way easier? Yeah, love that. Okay. Then we can cross multiply that. 2 times 327 seems a lot better than 400 times 327. Because this ends up just being 654 is equal to 3D. Okay? You don't even need glasses. Okay? So divide both sides by 3. And what do we get the D, our distance, to be? 218 feet. Okay. Questions on that one?
You're like 20.
Mm-mm.
You're still getting older.
I'm ancient.
You're 20.
No, I'm not.
You're like 5 years older than
Mm-mm.
me. That's not old.
I'm not 5 years older than you.
He's about like 25.
Older than your
I basically have 1 foot in the grave.
What?
That's the wrong one.
Oh my god. Oh, so great, bro. You're just like,
Did you just fall?
no, that's your
No. Did you just lie?
Yeah.
Okay. At least you're honest about one of these things.
I'm sorry.
Good luck.
No, I'm saying sorry for
Okay. Hey, yeah, I gave you guys the wrong worksheet last time.
Oh.
Okay. Do you guys remember that? Maggie just reminded me of that. She was so gracious. She reminded me. Yeah, you gave us the wrong one last time. She was really nice about it. Those no. So thank you for being nice about reminding me that I gave you the wrong one. Yeah. Oh, it's not fine. But
All the time.
is that why Peyton laughed? Is that why Peyton laughed?
Literally what we just learned that. Like,
Not loud. Watching you dance.
6.7.
Oh, why is it dangerous if you're always nice?
It did work.
Boom, lawyer. Okay.
I love you, Mag.
Hey, so raise your hand if you need this orange worksheet. Some of you guys gave it back to me because you're like, don't trust myself or you just weren't here, okay? I super don't blame you.
I don't trust myself.
So raise your hand if you need this orange
I
worksheet,
remember
okay?
Oh, who's this rolling paper? Cares? I can see your erase also you had you were there. It's okay. Yeah, when I said please, and I cares.
Oh, yeah. You,
Okay, fine.
so, you want a couple don't do's?
Yeah, sure.
Fine, sure.
11 and 12.
So, don't do.
How about 1 through?
No, 11 has a dinosaur on it. Okay? Don't do 10 and 12. We're gonna do the dinosaur. Why would you guys want to skip out on the dinosaur?
I don't know.
I didn't see the dinosaur covered up. It was covered up by my calculator.
Oh.
I apologize.
Yeah, you should. I forgive you though.
Yeah, I try to be pretty gracious. Oh, also, on number 9 and 10, on number 9, or excuse me, not 10 because we don't do 10, on number 9, it says to find the missing, this says D, and then what's the line say? H equals. Watch. It's supposed to be D equals. So that's one other thing, I fixed it after I printed it, and I was like, wait a second. So heads up on that. So number 9, it should say D equals instead of H equals, okay? There's no H. I'm not trying to trick you. Okay, yeah. So I'm not trying to trick you, but just heads up on that. Hey, otherwise, yeah, that's what we got.
This one mine.
Really call you a town.
Mr. Waffle.
What's up?
This is. Oh!
This is what?
You're just so bad.
Huh?
I was gonna
Thank you.
say I'm confused, but I can't see that because
No, that was pretty wise of you. Good work. I'm impressed.
He's gonna be like,
Give us one.